Bill Alec actually had a question. I'm wondering if I could put Bill on.
Yes, Tim. David.
Yes.
Could you describe mass as a field effect?
My dad could, but I would hesitate to launch into that subject because I'm strictly an amateur at the details of the theory. I can paint a broad general picture, but the short answer is yes, you can.
Okay.
Because everything that reality exhibits itself in only two ways. One is matter, that's mass, and the other is radiation. But at the elementary particle level, one is convertible into the other, as we know by fissionable nuclear weapons, right? So because one is convertible into the other, there's really only one field, the matter radiation field. That means mass and radiation are the same at the fundamental level. So you have a field within everything.
Right. Yeah, so if you look at the electron, for example, and the field equation for that electron, you know, let's suppose this Coke bottle here is an electron.
Yes.
The actual mass of this electron, you know, physicists, they want to put mass inside of something. Okay.
Right.
But when I did the math on this, I discovered that the mass is actually on the outside of the electron and can be expressed as a field effect. Okay. Well, and the reason for that is that the equation is governed by the inverse square law. Okay. So if you put mass on the inside of this Coke bottle, your equation, it's going to literally crush itself due to a singularity of that R squared effect. Okay, so the mass really has to be on the outside of the electron.
This is a question for my dad. I know that he had a mathematical way of expressing particles that as moving fields.
Right.
So you probably would like to read that.
I would agree with that. And you can describe this as like a primordial field effect. And I think they call that the Higgs field. Okay, that would surround the electron and would literally create the electron, would be a vortex of this spinning whatever, you know, this Higgs field effect. And so the inside of the electron would actually be a void. Okay, there would be nothing inside the electron. All the fields, the mass, the charge would be on the outside of the electron.
Yes, and what you're showing is that when you have a visualizable theory, as opposed to a mathematical model, you can manipulate it in your mind and make predictions. You've just predicted something, see? So that's good science as far as I'm concerned.
Well, you know, I show that with two gyroscopes that are epoxied together. And when you spin up these gyroscopes, there's a cancellation of angular momentum that occurs with this. So you have a counter-rotating system here that essentially would cancel out the angular momentum, which can be regarded as what? Rotational inertia. Okay, and you can actually cancel that out.
So the gyroscope just stands like that and it doesn't rotate? Is that the effect?
Gyroscope would have a counter-rotating disc. Okay, but if you spin up one disc, it has this rotational inertia. In other words, it resists a change. You know, it actually, I think, creates a mass effect just by using rotational inertia. But the electron, it would be, you know, you can consider that as like a rotating vortex. Now, I did the math on this too, and I discovered that this vortex spins at something like 26 times the speed of light.
Oh, wow.
I mean, at the radius of the electron. But as you get further out from that electron, it drops off to a point where it can reach the speed of light at a short distance. It's about 5 times the radius from the center of that electron. And I'm saying that, well, okay, the virtual particle flux can form around this electron, and that's what gives you the speed of light. The origin of the speed of light can be explained that way. But that's.
Well, I think you'd be glad to know that within my father's theory of special relativity, the speed of light is an apparent barrier, not an absolute barrier. And it's quite possible to travel many times the speed of light, particularly if you're able to cancel the mass of your vehicle, which you would be able to do with this technology. And so I'm very optimistic about star travel coming probably within the next century. But for the time being, I think it's great. We can easily contemplate conquering the solar system as far as visiting all the planets and learning what's really going on there.
Yeah, well, let me take it over to Wayne. I think Wayne had a question about a mass field. And
yes.
Wayne, are you with us?
Oh, hi. Yeah, I didn't really have a question. I was just, just the idea that Bill was putting forth about the mass being kind of on the outside of the particle, or being something like a more of a an extension of, because we're kind of taught in classical physics the idea of this a particle being a ball, like a solid sphere.
Right. And that creates problems.
Yeah, I mean, it really breaks down, right, on when you look at it a little bit deeper. But the idea of something being more of I kind of visualize it as something like a vortex where you have virtual vacuum particles are swirling into this hole, right? Hole in the ether or something.
Yeah. Well, if you are interested in the origin of mass and inertia, I would consult The Unity of Nature and the Search for a Unified Field Theory, which is one of his publications that came, I guess it was in 1991 or so, but it's at Physics Essays. I gave the bibliography in the emails I sent. So, yeah, you can get that. And it goes into all of that. It sounds to me like you have the background to understand it too. So,
and David, are you doing okay? Because I know that you're fighting a cold today. So
no, you can see that. Yeah, I stayed up all night last night, actually taking care of a relative. So I'm a little bit on the exhausted side, and I have this tickle in my throat that might indicate a cold or, God forbid, coronavirus.
Okay, I was just worried. If you need to take a few minutes,
No,
go right ahead.
I'm fine. I don't need that. I don't have a runny nose or anything.
Okay, yeah, well, actually, Ron had a question. Let me put Ron on.
Sure.
Okay.
Ron?
Okay, and Ron, you're still
okay. Yeah, I want to make a brief comment on gyroscopes. One comment on gyroscopes, and I guess people are familiar with eutectic metals. A eutectic metal is an alloy that are basically solid. You put them together and they become liquids. And bismuth is a common eutectic. So you can get a liquid like mercury by blending alloys. Even though they're both solids, when you put them together, they will function. You could get a bismuth liquid mercury type of material simply by, I'll use the word compounding with another metal. So I think something is called Wood's alloy, very low temperature, but I'll end that. The other object before I go is with gyroscopes. When you bond two gyroscopes together, you destroy the precession of the gyroscope. The gyroscopes cannot precess. If you want to link to space or couple to space, you must allow the precession to go, because when they're bonded together, you get an internal stress between the two. It's like saying this will get you nowhere. So gluing two gyroscopes. My last comment, when I started to look how gyroscopes couple to space, I got into ship stabilizers. And what they did back at the turn of the, or I guess, whenever they had gyroscopes, 1890s, they took a keel. This is a keel, and they would put a spike on a keel, okay? They put a gyroscope like this on it. The gyroscopes would not precess. They built one ship. It was a rigid spinning flywheel. A flywheel is different than a gyroscope. A gyroscope has gimbals. They built a ship with a massive flywheel in it. They put it in the ocean and it flipped over. So if you want to couple to space, the main thing is you must work with the precession. And this goes across all levels. If you destroy precession, you destroy the coupling to space. So that's about it. I'm timed out. Nice meeting everybody for the first chance here. And so that's all.
Nice to meet you, Ron.
Thanks, Tim. Thanks, Dave. And I see Dave Mathis is there. We've got many people, and Alec, and was it Ojala, the guy? Yeah, okay. Well, I might email some stuff around, and it'll make things simple. And until next time, have a great holiday.
Thanks,
too.
Ron.
Okay.
Bye, Ron.
And let me see. Let me go to Jeremy Reese. Jeremy, did you have some questions?
Yeah.
No, I was just waving goodbye to Ron, and so I was just waving goodbye to Ron.
Well, and the reason I'd asked you is I know that you've been studying the Alzofon theory, as has, and I've been quietly pestering Wayne and Jeremiah as well for questions, because you guys have been very deep into it. And so I thought you guys would have some really insightful ideas.
I got some questions from the live chat. People wanted to know how far Mark has gotten with his experiments and the replications that are ongoing and the continuation of David's father's work on this experiment. So we had some questions about that.
Hey, I'm here if you want to hear from me.
If anyone has any questions in the live chat for David directly, please post them, and I will.
I wanted to add one more thing about the slow rotation of UFOs.
David, I have your demonstration coming up. The demonstration you did on YouTube. I have the a bowl and everything. I'll set it up for you so you can explain that.
Oh, okay, sure.
I was just about to set that up, but first of all, I want to show you guys what's going on in the lab. So we tried the Alzofon experiment, and it was a little rudimentary. We only had 20 watts of power available. That's 20 watts coming out of the horn. Now, not all of that made it to the sample. So the amount of energy that actually made it to the sample was probably less than a watt. And David had mentioned that the sample heated up within seconds. So 1 watt is not heating up your sample in seconds. We must be dealing with much higher values, and the waveguide that is, compressing all this energy into one spot is critical as well. Tanya over here offered to help with that. And she's in Philadelphia and might even come down to the lab to see our work. I met up with a guy in the park today at the dog park who actually works at a CNC. They make special parts for SpaceX. So I asked him if he could make us some custom waveguides, because they have all the equipment there already, and he's game for that. We're taking the experiment to the next level. I have this power supply over here. This was actually found by Jeremy Reese, who got it for dirt cheap. But the most important thing is that this piece of equipment is actually very difficult to find. The reason why we need a 5,000 volt half an amp power supply is in order to power a klystron. A klystron is a type of vacuum tube that amplifies microwave energy way more powerful than the CW, the traveling wave tube amp that we have over there. That one is capable of outputting 3,500 watts versus the 20 watts that we have available now. So we're going to be able to take this experiment up many orders of magnitude in terms of the output of the of the RF field. Also in terms of the electromagnet and the laminar magnetic field, because there's two components here. You have to have a homogeneous magnetic field, and then you have to hit it at the Larmor precession. Also, the Larmor precession is sometimes not exactly, based on your equipment. You have to sort of find it. So what we're going to do, and we've made contact with a guy in another guy in Canada who works as a software engineer for a company with NMRs, and he actually knows how to combine the basically the data acquisition card information that's coming into a computer, and he's able to control the electromagnet and the microwave or the megahertz ranges and combine them together so that the equipment gets its maximum effect, the NMR effect. So he thinks that we could do the same thing with Alzofon, with dynamic nuclear orientation, by attaching the scales measurement coming into a computer. We're talking about basically making a robot do the experiment for us. I'm not sitting there twiddling dials for an hour or two. We can have a robot automatically make the combinations, control the current going into the electromagnet, and then control the gigahertz signal coming out. Actually, I plan on doing this, very simply, because the equipment Jeremy brought over has a lot of tuned microwave guides, and I wanted to show these to Tanya 1 second. Let me get them.
In the meantime, what Mark is talking about with automating the experiment. Go ahead, Mark. Now you're back.
Let's just continue. So basically, these are all tuned to a very specific frequency. I'm not even sure what all of them do. Maybe you could tell me about this a little more, Tanya, but it's basically 6.286.195 megahertz, 6.2 gigahertz, basically. And they're tuned all the way down. I think this is on the magnetic component of the wave. Am I reading that correctly? Oh, you have to unmute yourself. We can't hear you.
There we go. I don't really know. Without doing measurements and testing, I don't know what exactly you've got there.
So let me show you. Basically, it's a waveguide, and it has these bars that are going in between. It's sort of like blockages, and I think they are spaced exactly at this frequency, because that's what it says on it.
Right, I can see that. It's just that I don't know what to say about the electric versus the magnetic field component. I don't know how that's working unless you actually do measurements between all those things, and I can't tell from looking.
I'm saying the electric component is going this way through the waveguide. The magnetic component goes that way, and they're blocking it off along the magnetic component of the wave.
Well, you could do some tests to make sure that that's what's happening by what's coming out.
Right. We just get the Yagi antenna and spin it around. I have seen pretty dynamic orientation in the RF field coming out of our current setup, which also has a tiny little emitter antenna, and that is the electric component, of course, and the magnetic component comes the other way. So, and I'm not really sure what creates the dynamic nuclear orientation. Are we coupling to a magnetic effect in the electron's Larmor precession, or is it an electric effect?
Well, Mark, let me ask now. So based on what you're doing, and it looks like you guys are following the Alzofon theory, right? So based on that, do you have any anticipated amount of weight loss that you're shooting for, or you hope to see?
I mean, according to David, they saw around 80% within less than a second, but the sample heated up. So there was some inefficiencies in that. And they were using a lot more power than we did with this past experiment, in which we did see some results. Me and Jeremiah got very excited one night when we saw like 50% equivalent weight loss, and we were about to pop out the champagne until we realized that it was actually just affecting the scale, and we needed to ground it a little bit better. I have some equipment coming in, like some really thick grounding cables that are going to ground the scale and get rid of all that noise altogether. But it's very important to do your due diligence before publishing anything, because there's a lot of mistakes that can be made when you're dealing with microwave energy inside of a Faraday cage, and it's all bouncing around each other. Another important thing that we're doing is we're going to be building basically the equivalent of a fish tank behind the sample, we're going to make it out of wood and whatever, like make it watertight, and it's going to be filled with salt water. And the reason for that is the salt water will absorb the excess energy that was released from our device, and make sure that it doesn't bounce around and affect the sample from other directions, possibly, you know, destroying the orientation. So there's a lot of different things that you need to consider when working on this. We're also going to we also plan on building a larger laminar magnetic field using larger iron cores so that we have more room to play with our samples. There's a lot of things going on, and Jeremiah is going to come down to the lab and we're going to work on this together.
Now, do you think, I mean, there's the reports with like superconductors and Pogleinoff and stuff like that. Do you think that this same model, do you think that the Alzofon model would also explain that? And the reason I ask is one of the things they've talked about is Cooper pair electrons inside of superconductors, you know, but I mean, you've got a lot of things on the molecular level that seem like there might be similarities.
Yeah, there might be. I mean, we're trying both. We're getting superconductors, and I was also looking at super insulators, which are kind of interesting. So if you put a superconductor and then a super insulator, I think it's a zinc compound for the super insulator. Then you have another superconductor. And interestingly enough, to make a super insulator, you need cryogenic temperatures. So all you got to do is combine the, combine all three together, stick it in a jar of liquid nitrogen, and voila, you got yourself a superconductor, super insulator, superconductor, capacitive plate, and then you can pulse it with our massive, flux impulse capaciting machine, and we'll see what happens. And I am pretty certain I'm going to see something there. I'd be very surprised if something didn't show up. I've heard from many people, including people from NASA, who've tried this experiment, and it did work, but only when done correctly. If you miss any of the components, it will not work at all.
Interesting. Oh, I'm sorry. Go ahead, David.
Yeah, I just wanted, before the time slips away and I'm not able to say anymore, I wanted to talk about the flex. This is one of the things that makes a theory so interesting, is that it predicts such things as the flex in the cover paint on the flux liner. And what you want to do is achieve dynamic nuclear orientation. So you choose, and you don't want it to decay quickly. You want it to persist as long as possible. Aluminum is the best material for that. However, aluminum is paramagnetic. So it's difficult to influence it with a magnetic field for any great period of time. So what you do is you find a material that responds very quickly to a magnetic field, such as iron, and you coat the aluminum with the flex of iron, could be another substance. But then when you subject it to the microwave field, it's very easy to flip the electrons in the iron. They're precessing around the magnet. They're magnetic, so they're going to be precessing strongly. And then you hit them at a right angle with the microwave field, and they're going to flip very easily. They will transfer by magnetic moment. This answers another question that came up earlier. Their energy to the nuclei of the aluminum atoms. And so you leverage the iron flex, which you see in the flux liner, to affect the nuclei in that hull. And that's the reasoning behind them.
Wonderful. Well, thank you. Sorry, I lost my mouse for a moment.
Oh, okay.
Yeah, thank you. And does anyone else have questions? Let me see. Wayne has questions. Wayne, would you like to go ahead, sir?
Yeah, just going back to the discussion about power levels and the sample heating up. I was just thinking about how what happens internally is in the situation where there is polarization, like nuclear polarization, there's a loss of internal degrees of freedom or an increase in entropy, which would result in kind of like how in a refrigerator with the when the refrigerant is squeezed,
I lost Wayne's sound.
Yeah, Wayne, I think you faded out on us. Jeremiah, you had said that you had some commentary. Oh, wait, Wayne's sort of with us. Okay, I think we just lost Wayne.
No, sorry, I'm here. I just don't have the video on right now.
Oh, okay, yeah. Keep it on as long as you can talk. I think that probably saves bandwidth. Were you almost
coming through?
You dropped out for a bit. Do you want to retry the question?
Okay. So the question was, it's sort of more of a comment. I guess it's a question. I was just in consideration of the temperature increasing in the sample. What I was thinking was as the process happens, that the internal degrees of freedom are reduced, and the entropy is reduced. So that latent heat in the material would have to be shed, increasing the temperature. So that would result in an increase in the temperature when the orientation is happening. Sorry, guys, I'm going to have to mute here.
Oh, okay. I'm sorry, Jeremiah.
I believe what Wayne was asking there was, the observation, David, by your father, that the sample heated up really, really quickly. What Wayne's talking about is a theory that states that if you were to change the orientation, the coupling to this field, or you were to lose some mass or inertia, that the thermal energy contained within that material will also be immediately apparent on the outside of that material, effectively because its time has been slowed down. So the quantity of waves or the quantity of emitted radiation over a given period of time would drastically go up. And we may observe that as a significant increase in temperature as a result of this effect taking place, not necessarily because the sample itself is hot, but because it seems to be radiating a very large amount of heat according to our measurements. I think he was asking about what your opinions on that specifically were.
I really can't offer a good opinion on that because I'm not entirely familiar with the processes that he's talking about. Pardon me. I would only say that you can really investigate it once you set up your experiment and make a determination on what is causing the heat, if you're getting the heat. But I think your goal experimentally is to be able to cycle these impulses, the square wave impulses of the microwaves, for many more times than 2. And if possible, to use a heavier sample so that this would be more impressive to people who would look at the sample and say, well, it's so light anyway, it could be a piezoelectric effect or something like that. And so you want to impress you want to impress the world. And collect
we agree completely. We want to get away from the noise floor problem. And Mark and I have spent so much time, Mark Sokol and I have spent so much time just going through and trying to eliminate the noise floor, reduce all possible contributions to measurement error. And I think that I would actually say that our attempts to eliminate measurements errors have probably taken up more time than any of the experimentation itself. And it is a tremendous learning curve when dealing with high power microwaves. And now we're about to go into a whole new territory too, David, when we enter into this klystron stuff and we start to work with very high power fields and very high power impulses. Shielding, well, I guess we're going to have to figure that out as we go. And of course, we constantly want and accept any input by anybody else on how to shield the scales, protect the measurements, and get better data.
If anyone has experience with an electron spin resonance spectrometer, I'm sure that would be very helpful for you guys to be able to talk to them. So I don't know how many people are in the wings here, but when I was speaking up in Idaho, at the energy conference in Idaho, ESTC, Energy, Space and Technology Conference, Energy Science and Technology Conference, which is put on by a friend of mine named Eric Murakami. somebody stepped out of the audience afterward and offered to explain how to achieve dynamic nuclear orientation much more easily. Unfortunately, I didn't get his name, so I can't call him up on the phone and ask. I should, since you guys are approaching the point where you're going to run another experiment, I should probably make more effort. It's possible Aaron knows who that was.
Yeah, we would like to certainly talk to this individual, and anything that they might have to input or maybe boost us along would be very welcome. Of course, we want to share all these results with everybody, so that would be fantastic. The other question I had for you, and I wouldn't necessarily ask if you already know about quantum electrodynamics in depth, but I should ask if you heard of it.
Of course, yes. In fact, one of my dad's papers has a section on quantum electrodynamics and a new way of looking at it. So, yes.
Well, let me ask you this then about quantum electrodynamics. In that theory, there is a concept presented, and this concept is presented not just there, but in a lot of different theories, and it's the concept of an information horizon, wherein you have a field of a particle, a charged particle, or the magnetic moment of a particle like a neutron, which is changing its orientation. And this information doesn't instantly reach out to the depths of space in every direction. It takes a period of time to travel, and as a result, if you just measure it statically, you can end up with a fairly accurate measurement of where it sits and how strong it is. But if you have this field changing in its orientation, the fact that it's changing constantly means that you end up with these field transients that take a period of time to get from where the particle moved or where it precessed or changed its orientation to any outside influence. So if we go into or quantum electrodynamics and consider that dynamic nuclear orientation is involving the nuclei aligning and not being able to respond to the gravitational field, and also the fact that the electrons have their own fields and they're radiating out energy. Quantum electrodynamics does predict the decoupling of the particle producing the charge, or the particle which has the charge, from the external environment. And then you could go farther and to say that the universal gravitational field, or what you call the background radiation, that is coupled to this thing, and this is what sets up the amount of space in space. I was wondering, if you had any inputs on quantum electrodynamics or its relation to that.
Well, I'd have to go back to the paper and look at it. I'm sure that, I make my standard excuse that I'm sure my dad would have had a response to that immediately, but I can't say that, I can't pretend to know about that or enough about that to make to have an opinion on it.
Thank you very much anyways for the input. We will certainly, if we find something about it, tell you all about it so that we can all know.
Well, look in the Unity of Nature, because that's where you'll find it. Quantum electrodynamics is in there. I think it might be in the 1981 paper too.
Okay, David, we have this experiment set up, the one that you showed in the bathtub.
Uh-oh.
Yeah, basically I have this little disc over here, and it's basically a plate, and I got a fast spinning gyroscope.
Do you have a weight to put on the other side of the plate? Because you want to balance the plate so it doesn't sink on one side.
Yeah, that's becoming a problem. It's also shaking a bit. Let's see if I could get it to stay in one spot. Oh no, I'm gonna have to find a way to attach it to the plate a little bit better, because it's
sure
shaking too much.
The plate that I used, you guys, is I bought it at Walmart during Thanksgiving, and it was a candy plate or treat plate, the serving tray, about that big, at least 12 inches across, and took completely flat. So I put the gyroscope on a stand on one side of the plate, and then I put a counterweight on the other side of it, and it immediately began to show this slow rotation that has been described in the case of UFOs. And it is a model of what's going on at the level of elementary particles in the skin of the UFO. The gyroscope represents the electrons, and they are precessing around a single axis, and it's not just one of them, but it's the entire shell of the craft, because they're going to have a powerful electromagnetic in the walls of the craft that's going to set up the precession. then they're going to flash a microwave impulse from the center of the craft, and it's going to spiral out from the center and knock over all those electrons. But I'm focusing on the point where it's precessing. The precessing electrons will induce a slow rotation in the hull of the flying saucer. That's what people are observing. And I just modeled it by putting a saucer, a literal saucer, in a bathtub and putting a gyroscope on it, which represents the electrons precessing and the counterweight. And let me tell you, it may sound trivial, but it really blew my mind to see that happening, because it made me think, wow, this is not only further confirmation of the theory and the technology, but this explains something that has baffled a lot of people, including people with the intellectual caliber of Neil deGrasse Tyson, who sarcastically said, "Who would build a spacecraft that spun like that? It's a waste of energy." And clearly, he didn't understand the propulsion system.
Yeah, yeah. Well, and I think that makes sense. It's very, it's kind of a niche interest and it's a niche knowledge, right? And I think it takes a lot of research to kind of put a lot of the pieces together and understand why you would go that direction with it, right? And so,
yeah. Well, what I like Neil deGrasse Tyson. I don't mean to ridicule him, but he's ridiculed UFOs so often. I feel like turnabout is fair play. A little bit of turnabout, tiny little bit. So he could do the bathtub experiment, and I'd like to hear what he said then. Might be an interesting response, because he does seem basically open-minded as long as you can get him to look.
well, and I see Mark's feet there, so hopefully we will have. Hopefully he'll be back here. He can do this experiment. We can see what's going on. Now, does anyone else have questions? It looks like, let me see. Wayne is talking about the Einstein de Haas effect, which is the reverse of the Barnett effect. And then we just had Tom Vallone join, and we've had Rob Chambers in here. Not too long ago, we had George Hathaway join, and so I think they're just lurking. But
Yeah.
Can I comment on that? So the Einstein de Haas effect, yeah. So what was observed is that when magnetization happens, it induces weak rotation, like in like an iron rod. That's what was discovered experimentally, anyways. So if some sort of polarization is happening in each craft, then it would stand to reason that, the spins would be, if the spins are synchronized, then they would induce a rotation in the entire craft.
It would.
So,
and the rotation would die away as the weight of the craft diminished. Also, they might be creating a counter spin motion just to stop it from spinning. But something seems to happen at the moment that the gravity is no longer affecting the craft. It seems to change from wobbling to turning very steady. And it's only a moment later that it will zoom off into space. Yeah.
But would the rotation of the craft be caused by the alignment of the nuclei orientation as a result of their now gaining possible angular momentum, now being aligned in this field?
Okay.
Basically, as if they were little gyroscopes spinning up or something, they were all in different orientations and they line up. If you spin up a gyroscope, the outside body has to experience a counter-rotational force, and if it's not held down, it'll rotate. I'm just wondering, as this orientation is taking place in the early stages, is it as a result of the angular momentum being vectored down to basically one direction, or all aligned?
That's what I was getting at there. I was just saying that's what I was getting at there, Jeremiah, with the Einstein-Haas effect. You can look it up on Wikipedia. Go ahead.
Yeah, it's fascinating how and then we have the sudden appearance of charges as well, or an appearance of a spontaneous magnetic field. It's a really fascinating phenomena just by sheer rotation.
Yeah, yeah, absolutely. Well, and let me see. Now, does anyone else have questions? I think we're getting to that.
Yeah, I had a question too. Two questions. I have one for David regarding this microwave thing. I think we had mentioned in the other the stream we did a couple weeks ago about data that was collected by Project Blue Book and Dr. Paul Hill. It was talked about. There was a case where they had taken microwave. They actually got microwaves from a UFO that they encountered. The U.S. Air Force had actually recorded microwaves, and that data could possibly be related to the propulsion system or something like that. And then
RB-42 incident, I believe Ron Kita was saying. RB-42, I may be remembering that.
That was from the other one. RB-42, right? Is that what it is? RB-42?
What year was that?
I could have the number.
I'm trying to find that again so I can look that up and link that. I've been trying to find it since we talked about it, and then I can't find it anymore. I have to go back and review that live stream. But the other thing was Mark had done the experiment with the tub and and this gyroscope thing. I had seen another experiment and an explanation on gravity that I had watched before, and it was this whole thing about they took two boats in a bathtub, and then they just put it like in something in the bathtub to make waves, just random waves in the bathtub. And these fluctuations in the bathtub were damped between the two boats, and they found that the waves in the boats would just float around each other, and they'd eventually come together and touch, because that's when the waves, that they wouldn't have this interference in the waves between the two boats. And then
Jeremy, you're talking about the analog of the Casimir effect using water waves to demonstrate how the Casimir forces are generated by rejecting certain wavelengths between these two boats of the waves on the water.
Yes, absolutely, and that's very much like a good description of what gravity is and how we can basically eliminate it. I don't know. I thought that was very relevant, and seeing the water experiment, I'm like, wow, why don't we do the thing with the two?
Check it out. It's actually working right now.
Ah, there you see the spin.
Let me see if I can change the lighting so you get a clearer view.
I think the spin when you use a wider plate is slower. At least that was my experience.
Well, it might be conservation of the angular momentum or something. Yeah, that's weird.
You could
notice that the gyroscope is on the side. It's not in the center. So
it should be on the side.
Yeah, you can't argue that it's the friction against the air or something like that.
Whoops, it's tipping over. Yeah, if I had enough money to buy a bunch of gyroscopes, I would put them around the plate, at least 4 of them, and see what happened.
Now, could I ask again from a kind of a novice layman's perspective, what is that demonstrating in terms of your father's theory?
Okay, if you can imagine the hull of a flying saucer, it's like a radar antenna. In fact, it's like 2 radar antennae clapped together in the center, and there's a reason for that. You want to use the hull as a way of dissipating the gravitational field around the craft. You can propel the saucer any way you want to after that when it becomes weightless. But this is the most efficient way to deliver the microwave field and the magnetic field to the hull, is to put a post into the center of the craft and broadcast it at the top of the craft so that it comes out from the center and spirals around the craft to the outside. This is exactly what it looks like when you put a radar antenna up and you broadcast a signal out. It will spiral like that. Okay, so now what's happening in the hull? The hull is made out of aluminum, and it has those it has that dusting of ferromagnetic material. And you're subjecting the hull to a magnetic field, which is causing the electrons in the hull to precess around the same axis, like this. And during the phase when the electrons in the hull are precessing like this, that movement alone is enough to induce slow rotation in the hull. And the transference of energy from the electrons could be, it's definitely the magnetic moment of the electrons influencing the nuclei. So, but it would also be influential if the hull still had mass. So in either case, it's going to cause the hull to rotate.
I see what you're
May I
saying.
ask for clarification?
Sure.
So if I'm understanding this correctly, please correct me if I'm wrong.
Sure.
So as the electron's precessional or rotational angular momentum is transferred to the nuclei, effectively because you're transferring this rotation of the electron into the nuclei, the electron experiences a counter torque, and because it's the thing that we're observing, the electron's counter torque in acceleration of the nucleus and orienting it actually causes the counter rotation. I know that was a complicated thing to say, but is that kind of sort of close?
I don't think so. Well, I don't know for sure. I'm not a nuclear engineer, but what I was talking about was the precession of electrons, which when you send out that microwave, that flash of microwave energy, you cause the electrons to flip over. And when they flip over, the nuclei of the aluminum atoms also flips over. And that's dynamic nuclear orientation. Now, whether that induces momentum in the hull, I don't know. I stopped at the point where I was sure that there would be transference of angular momentum from the electrons to the nuclei in a small sort of way. That subject is taken up in one of those MUFON papers you have. I sent you two, or at least two of them. And one of them was on crop circles. I think if you look at that one, you'll find what he says about the slow rotation of the hull, but it could be in the other one too. That's what I use as a basis of the experiment.
All right, thank you very much, David. I appreciate that.
Wonderful. So Bill had a question. Bill, wherever Bill's at. Sorry, I've got too many of these windows open.
I just say I shut off the lights so that I noticed there was a glare in the camera before. So I shut off the light in order to shut it off, in order to get a better view. Also, what I'm doing here is I have clay as a counterbalance, and I used a little bolt over there. It's all attached to a strip of tack, so you can move the gyroscope to different positions. But I don't think I can do anything other than the opposite side, because this counterweight is barely enough, and I risk capsizing the whole thing.
Okay, so let's go to Bill. Bill, what was your question?
Yeah. A few years ago, I met this researcher by the name of Dan Davidson. And he mentioned to me, well, he gave a lecture on this researcher by the name of Larry Wilson. And Larry Wilson was sponsored. Now, this was back in the 50s. Okay, he was sponsored by Bill Lear, from Learjet, because Bill Lear had a real fascination with UFOs at that time. And Larry Wilson was a researcher doing research with anti-gravity. And there's a whole article written about this in a magazine called Young Men's Magazine. And I sent Tim here some research that I've done in the area, putting this all together. And Dan, he was a kid at the time, and he used to hang out in Larry Wilson's research lab. And he says, Larry really built this device. It was a counter-rotating system that had these El Nico magnets set up in an opposing configuration, okay? And he said that when Larry would fire up this device, with this counter rotation going on, the device would actually just lift off the floor. And so Larry did a few experiments with this, and Dan Davidson has, basically the rest of the story there. But I kind of consolidated all this work into a panel that I sent to Tim here. About the magazine article saying that, This was back in the mid-50s, saying that, well, we're going to have anti-gravity really soon here.
I'd like to make a comment.
Shortly
Sorry.
after that, everything went black with this technology. But anyway, Dan gave a talk about this a few years back. There's a video on it that can be, I guess, purchased from Tesla Tech. And it's a counter-rotating system of opposing magnetic fields, and I strongly suspect that this is what the Germans were doing with the Nazi Bell device. They were setting up counter-rotating fields to break entanglement to get this to float off the ground. So that's kind of like my read on all this.
I'd just like to say that this illustrates why my dad didn't like the term anti-gravity, because what he developed was not a way of pushing back against gravity, which is what this device sounds like it's doing. He found a way to deplete the energy of the gravitational field. In other words, to reduce the effects of gravity and inertia on the vehicle until it was weightless and inertia free. And that's the only thing that would explain these extreme flight characteristics that we see in UFOs, the ability to alter gravity and inertia. So he didn't like anti-gravity, and that's why he termed it gravity control. It's a very nice looking flying saucer there.
That's why we also changed the name from the Anti-Gravity Engineering Conference to the Alternative Propulsion Engineering Conference. Even though the word anti-gravity has quite a bit of history, trying to explain how flying saucers operate, it does get some people in a box of thinking anti-gravity, like in a literal form. We actually had this conversation on the WhatsApp group that I was pushing before, and we came to an anonymous conclusion that alternative propulsion really explained the effect most efficiently. And we were talking about, let's get a new email address, for the APEC conference. And Jerimiah told me, why don't you check if alternative propulsion at Gmail is available? And I told him, there's no way in hell that email address is available. I said, if it's available, I'm a horse, So it turns out that maybe I have to start eating grass, because it was available, and I was shocked that it was available. Somebody must have kicked whoever had it out, in the past, because this is way too much of a coincidence. And I love the name Alternative Propulsion Engineering Conference, and I think you guys do as well. And it also spells APEC, so you can have a nice acronym for what this conference is really about.
Mark, let me jump in. We have a question from Alita and Douglas. They have their hand raised. They've actually had it up for a while. So let me see. Alita and Douglas, are you with us?
Yes, thank you. Alita is my wife. She's stepped away, but this is Douglas. Doug, a quick question from Mark about the experiment there. I'm assuming, or intuiting that the direction of rotation of the bowl is the same as the spin of the gyro. Is that true or not?
Yeah, it's the same direction as the spin of the gyro, and the gyro's precession is the same. So there's a lot of spins going on here. There's the spin of the gyro around its axis, and then there's the spin of the axis, which is its precession. And then there's the precession of the bowl, and they're all spinning in the same direction. And I just had a brain, storm. What if I put two, one on either side, both spinning in opposite directions? Would that move it forward?
Oh man, I love that idea. I completely love that idea. So what you're saying that as the gyroscope is decelerating, instead of it experiencing a counter rotational force, so that the entire disc spins in opposite direction to the present rotational direction of the gyroscope, it actually accelerates in the same direction, which would be counterintuitive to the frictional forces.